Good morning, ladies and gentlemen. Today we'll be talking about properties. The first two properties are probably the most important ones. The commutative property, which means that we can change the order of the numbers and the sum or the product remains the same. For example, 3 plus 5 is equal to 5 plus 3. We have 8 on both sides. We can do it with variables. A plus B plus C equals A plus C plus B. And sometimes you'll see this, A plus B plus C is equal to B plus A plus C. Notice that the variables change places inside the parentheses. That's the commutative property. The commutative property of multiplication works the same way. 3 times 7 equals 7 times 3. 3 times 7 is 21. 7 times 3 is 21. We get the same answer both ways. You can do A times B times C equals A times C times B. If the numbers move around, that is the commutative property. The commutative property only works for addition and multiplication. The commutative property does not work for subtraction or division. The associative property is similar, but in this case, the parentheses are going to move, not the numbers, or not the variables. So if we have 5 plus 3 in parentheses, plus 2, is equal to 5 plus 3 plus 2 in parentheses, we should get the same answer. 5 plus 3 is 8. 8 plus 2 is 10. 3 plus 2 is 5. 5 plus 5 is 10. So even though the parentheses have relocated, have moved, we got the same answer. It works with variables as well. A plus B plus C is equal to A plus B plus C. The associative property also works for multiplication. 3 times x times 4 equals 3 times x times 4. Or with variables, A times B times C equals A times B times C. I don't want that. I don't know what that's doing there. Notice that the variables have remained in the same order. A, B, C, A, B, C. It's the parentheses that have moved. It's a grouping property. Notice that B is hanging out with A in the first half, and B is hanging out with C in the second half. Change who you're associating with. That's the associative property. Okay, identities. Identity means you end up with the same thing you started with. So if we start with 8, we want to end with 8. What are we going to add so that we end up with 8? We will add 0. That works for variables as well. X plus 0 equals x. So the identity means that we end up with the same thing we started with. So if we're multiplying and we want to end up with 8, what are we going to multiply by? We're going to multiply by 1. Works with variables as well. X times 1 equals x. So the identity means that we want to end with the same thing we started with. We start with 8, we end with 8. The inverse properties use the identity in a different way. If we start with 8, we want to end with the identity, that is, end with 0. What are we going to add in order to end with 0? We're going to add its opposite, which is negative 8. So 8 plus negative 8 equals 0. That is the additive inverse. Works with variables as well. X plus negative x is equal to 0. For multiplication, let's say we want to end with the identity, which would be 1. What are we going to multiply by 8 in order to get 1? We're not going to multiply opposite. We're going to multiply reciprocal. That is 1 over 8. 8 times 1 over 8 equals 1. We can always put a 1 under a number and make it into a fraction. And whenever we multiply reciprocals, we will get 1. So x times 1 over x equals 1. 3 over 2 times 2 over 3 equals 1. So notice the answer to the inverse is the same as the identity. The identity of multiplication is 1. The answer to the inverse is 1. Okay, then we have three properties called reflexive, symmetric, and transitive. And I think to myself, RST 1, 2, 3. That is, the reflexive property has 1 equal sign, the symmetric property has 2 equal signs, and the transitive property has 3 equal signs. The reflexive property just says that any number is equal to itself. X equals X, A equals A, 5 equals 5. 1 equal sign, one idea. We use this in geometry a lot, but we have to start getting used to it in algebra class. Symmetric property has 2 equal signs. If A equals 2, then 2 equals A. We're just trading which side of the equal sign things are on. Let's say we have if x plus y equals 5, then 5 equals x plus y. All right, the transitive is the exciting one. The transitive has 3 equal signs. If A equals B and B equals C, then A equals C. Notice that there are 2 A's, there are 2 B's, and there are 2 C's. 3 equal signs, 3 statements, each mentioned twice. Transitive property, very powerful property. We use this a lot in geometry. Let's say if 2 plus 2 equals 4 and 4 equals 3 plus 1, then 2 plus 2 equals 3 plus 1. The transitive property. All right, multiplicative property of 0. This is a fairly easy one. X times 0 equals 0. Anything times 0 equals 0. 25 times 0 equals 0. In fact, you can multiply a lot of things. A times B times D times 0 equals 0. If you're multiplying a lot of numbers and one of them is 0, the answer is going to be 0. Multiplicative property of -1 is very important in algebra. 7 times -1 is -7. Anything times -1 is going to be its opposite. X times -1 equals -x. Or negative x times -1 equals positive x. We need to start seeing a minus sign as a negative sign, a multiplication by -1. Here's what I mean. Here's a -6. How did this 6 get to be -6? It was multiplied by -1. All right, the distributive property. We're going to use the distributive property a lot in algebra class. Let's say we have 3 times x plus 5. How do we get rid of these parentheses? We distribute. I draw arrows. 3 times x is 3x. 3 times positive 5 is positive 15, and now the parentheses are gone. Sometimes you will be distributing from the back. Let's say we had y plus 8 times 2, and the 2 was behind the parentheses or after the parentheses. I'm still going to draw my arrows. Arrows remind me to multiply. 2 times y is 2y, and 2 times positive 8 is positive 16. And now the parentheses are gone. That's what I want. I want to get rid of those parentheses. Okay, so 5 times x minus 4. I'm going to draw my arrows. 5 times x is 5x. 5 times -4 is -20. I know this says x minus 4 inside the parentheses, but we need to see this as a -4 when we're multiplying. That minus sign belongs to that 4. So we're multiplying 5 and -4, and we get -20. Okay, properties of equality. We're going to use these to solve equations. Let's say I had x plus 4 equals 9. I need to isolate the variable, so I'm going to subtract 4 from both sides. That's called the subtraction property of equality. The 4's cancel out, and I get x equals 5. Okay, so we also have the addition property of equality. That means you add the same thing to both sides. We have the multiplication property of equality. And we have the division property of equality. That means we divide both sides by the same thing. Whatever we do to one side of an equation, we have to do the same thing to the other side. That's how we keep the equal sign valid. Okay, order of operations. Order of operations, some people say germ-DOS. I tend to say PEMDAS. I write the M and D side by side because multiplication and division are equal. We always read left to right in math class, and after we take care of parentheses and exponents, then we will do multiplication or division, whichever one we come to first. After we finish with those, we will do the same for addition and subtraction. They are equal, and I do whichever one I come to first, reading from left to right. All right, so G stands for grouping symbols. What are grouping symbols? Grouping symbols are parentheses, brackets, braces sometimes even. Absolute value bars are grouping symbols, and even a radical is a grouping symbol. E stands for exponents, and R stands for radicals. Exponents and radical. A radical is an exponent. So you don't see too many people saying germ-DOS. Some people say gem-DOS. I say PEMDAS. M stands for multiplication. D for division. A for addition. And S for subtraction. But we follow order of operations to solve, that is, simplify. Let's try an example. 2 times the absolute value of 4 times bracket 4 divided by -2, close bracket, plus 6, close absolute value bar, minus 5. Now that's a big one, isn't it? Do we have to follow PEMDAS inside the absolute value bars? Yes, we do. Do we have to follow PEMDAS inside the brackets? Yes, we do. Well, this bracket just has one thing going on. 4 divided by -2 is -2. I'm bringing down everything else. The 4, the absolute value bar, the 2, the positive 6. And I'm still following PEMDAS inside the absolute value bars. 4 times -2 is -8. I bring down everything else that I haven't used yet. I'm still having to finish inside the absolute value bars. -8 plus 6 is -2. Now I've used, whoops, I haven't used them yet, have I? Absolute value bars are still there. Now I'm ready to take the absolute value of -2. Absolute value is asking a question. How far am I from 0? -2 is 2 units away from 0. So when I take the absolute value of -2, I get 2. And I bring down everything else. 2 times 2 is 4. 4 minus 5 is -1. So that's my final answer. Simplifying using order of operations. Okay, here are your U-tries. You're going to write your answers down and take them and put them into the knowledge checks. U-try number 1 asks, what property is this? If 4x plus 9 equals 67, and 67 equals 4x plus 9. What property is being illustrated here? Okay, you try number 2. We know we're using the commutative property this time. Commutative property says if x plus 9 equals 14, then blank also equals 14. What would the commutative property say there? Okay, you try number 3. This is a PEMDAS problem, order of operations. 27 divided by 3 squared times 2 minus 3. Solve that. Enter your answer into the knowledge check. And one more you try. 27 minus, whoops, brackets around here. 27 minus 2 plus 5, brackets minus 2. Okay, there's your last you try. Bring your questions to class.